Welcome to the presentation on organic chemistry by Lenny, Hannah, and Peter. Fundamentals of organic chemistry. Firstly, naming of organic compounds. The naming of organic compounds is as illustrated by the picture on the screen. For organic compounds with halogens, the naming can be a bit different. The naming for compounds with halogens is also on the screen. There are different kinds of classes of organic compounds. There are alkanes, alkene, alkynes, alcohols, ethers, aldehydes, ketones, carboxylic acids, halogenoalkanes, amines, esters, and nitriles and amides, as seen on the screen. In organic molecules, there are saturated and unsaturated molecules. Saturated molecules are when all carbon molecules in the organic compound are bonded to a hydrogen. In unsaturated organic compounds, not all carbons are bonded fully to hydrogen atoms, and therefore there are double or triple bonds. Classifying halogenoalkanes. There are three types of halogenoalkanes: primary, secondary, and tertiary, just as shown on screen. Classifying alcohols is similar to this. There are primary, secondary, and tertiary alcohol molecules. Primary alcohol molecules are when the carbon bonded to the hydroxyl group is bonded to only one carbon atom. Secondary is when the carbon that's bonded to the hydroxyl group is bonded to two carbon atoms, and tertiary is when it is bonded to three. Amine molecules are classified by the number of alkyl groups bounded to the nitrogen atom. In primary amines, the nitrogen is bounded to only one alkyl group. In secondary, 2, and in tertiary, 3. Finally, aromatic hydrocarbons. In aromatic hydrocarbons, there's always a benzene ring present. There's also a 1.5 bond order. Pi electron bonding causes the stability of the molecule. The molecule readily undergoes electrophilic substitution. Now, onto the specific types of molecules and the reactions that they undergo under the standard level syllabus. Firstly, alkanes. Alkanes undergo three types of reactions: combustion, free radical substitution, and dehydrogenation. Under combustion, alkanes undergo two types of reactions: complete combustion, which involves excess oxygen, which produces CO2 and H2O, or incomplete combustion, where anoxic conditions are present. Free radical substitution occurs in the presence of ultraviolet light and a halogen. In this process, a halogen atom replaces the hydrogen. It occurs in three steps: initiation, propagation, and termination. Finally, dehydrogenation. Under dehydrogenation, alkanes are converted to alkenes. The conditions required for this reaction is heat and nickel catalyst.
Alkenes undergo two different types of reactions: combustion and addition reactions. Under combustion, alkenes can undergo complete combustion or incomplete combustion, depending on the oxygen environment. In an environment with excess oxygen, complete combustion will lead to the products carbon dioxide and water being formed. In anoxic conditions, the products of incomplete combustion are carbon monoxide and water. There are different types of addition reactions. The first type is halogenation. This is the addition of a halogen to an alkene. An example of a halogenation reaction is during the bromine test for saturation. The next type of addition reaction is hydrohalogenation. This is the addition of a hydrogen atom and a halogen to an alkene. The Markovnikov rule states that the halide, in this case, is added to the carbon atom with less hydrogen atoms surrounding it. The hydrogen atom is added to the carbon atom with a greater number of hydrogen atoms surrounding it. The next type of addition reaction is hydration, in which water is added to an alkene. This produces an alcohol. The condition for this reaction is sulfuric acid. The next addition reaction is oxidation, in which the oxidation number of the alkene is increased. The conditions of this are KMnO4, NaOH, and coldness. Lastly, polymerization is an addition reaction in which the molecule reacts with itself to form a long-chain polymer. Alcohols undergo 4 different types of reactions. The first one is combustion, which is similar to that of alkanes and alkenes. The second one is dehydration. This is removing one hydrogen atom and one hydroxyl group. This converts an alcohol back to an alkene. The condition for this is an acidic environment and heat. The third type of reaction is oxidation. The products of oxidation of an alcohol depend on what type of alcohol it is. Oxidation of a primary alcohol produces an aldehyde. Oxidation of a secondary alcohol produces a ketone. Oxidation of a tertiary alcohol will lead to no product, as a tertiary alcohol is resistant to oxidation. Lastly, an alcohol can undergo esterification. An esterification reaction occurs when an alcohol reacts with a carboxylic acid. This produces an ester and a molecule of water. The condition for this reaction is concentrated NaOH. This is a condensation reaction and also reversible as hydrolysis.